Okay, we're going to continue on with Chapter 7.3, and we're going to focus on side angle side. Probably one of the most confusing of the three categories that are given in that section. So we want to verify that the triangles are similar. We're given that these two angles are congruent, ADE and then angle C are congruent. And we're looking at this small triangle here in comparison to this big triangle here. Now remember, similarity is just taking a triangle and stretching it or shrinking it or some other, but the angles never change. The side lengths will change, but they're always going to remain proportional. So we somehow, possibly, we haven't proven it, took this big triangle and shrunk it to this small one, keeping all the angles. And also, we've obviously rotated and flipped it, did mirror image or something. So that's where it gets tricky. So we just can't compare same side to this side over here. We need to figure out where do we compare this 6 to a number over here, and where do we compare the 5 to a number over here. One technique, and once you get better, you don't really, you can just kind of figure these things out really quick. But one technique is just to simply split. Here's my original, and all I did was I just redrew this triangle, pulling them apart, and that gives me a better visual on how to compare these two triangles. Again, here's my angles. Here are the sides that include this angle. So this angle is included between these two sides. That means these two sides include this angle right here. So odds are I'm going to be comparing these two and these two together. If you look down at the bottom, we're missing dB, so we don't have every piece of the pie. And some problems later on, we probably will ask you to find what is the length of dB. That would be a very good question. So one technique, and it works very, very well, is take your biggest side of the small triangle and compare it to the biggest one of this one. Because we don't know dB, we're not sure what side this is, but I'm pretty confident this is the biggest side. So let's go ahead and do that. We're going to do, again, apples to apples, oranges to oranges. So I'm going to do 6 is to 12 and this is probably my middle side. Again, we're looking on the included angle. 5 is to 10. And guess what? They both come out to be 1/2. So there is a proportionality here. This is my similarity ratio, 1/2. I could have done it backwards and came up with a 2/1 for a similarity ratio. It just depends on perspective, small to big, big to small. So now I have a side, angle, side. And here's my side, angle, side. So I have proved that these two triangles are similar. Right in the similarity statement, you just got to be careful. You got to make sure that our angles line up. So C is congruent to D, B is congruent to E, and A, of course, is congruent to itself. And that leads us back. Now take a look at this. We could have cheated and done something else. We could have proven this using angle, angle. Because guess what? Reflexive property, A is congruent to itself, which means using the third angle, that is here. So we can prove similarity given angle, angle, angle. And that just simply works for one simple reason. Let's just say, I want to show you real quick. I'm going to draw a triangle, just any old triangle. And if I were to clone this, I have congruent triangles. But now, since I've stretched it out, I have similar triangles. The angles never changed. Doesn't matter what the angle measurements are, they're always going to be similar. These are going to be proportional sides. Let's take a look at the next one. This is not from the book also. I took this off a worksheet somewhere. And here we don't have shared sides. And we're given something very similar again. We're given that this angle right here is congruent to this one right here. So I'm going to take a look at these two sides here and compare them to these two sides here. Now, which ones do I compare? Again, let's go back. Here's my big side. This side is right here is 32. I'm going to write 32 right here because 24 plus 8 is 32. And so this is my big one and that is my big one. So I'm going to compare 32 over 24. I could have done it the other way. I could have done 24 over 32. And I'm going to compare that to the big one over the small one, over 12. I went from this triangle to this triangle. And these are going to simplify. Well, 8 goes into this 4 times and to that 3, so I got 4 over 3. And I better get 4 over 3 over here. Well, 4 goes into that 4 times, and 4 goes into that 3 times. Boom! I got side, angle, side. And I have proved similarity. Now let's write our similarity statement. Now we've got to be a little careful when we do this. So we can start off many different ways, but one technique is just go ahead and set up our little template here. We have triangle is similar to some other triangle. And sometimes it's best to start off with your known vertex. Again, you can start off with any letter you want as long as you know they line up. So M corresponds with L. So we're doing this small triangle to the big triangle. I guess I could have done it the other way around. And it looks like K is going to correspond with N. So we're doing M, N corresponds with K. And then J is at the end for both these guys. So it looks like J, this angle J, and this angle J is, because remember, we're splitting these two triangles apart. I can rip it apart, move that one up there, move this one down here, and we have our own vertexes. So just be careful how you write this. You could have wrote it another different way. You could have wrote J, M, N, and then J, L, K would have worked as well. Alrighty, so we will continue the next section shortly.